Hello, good morning all in this particular lecture of Sarthak Initiative. Uh, Today we are going to start with slightly some basics at first because I don't know the level is that the same for all the students or not. So that's why let us take today's day for understanding each other and understanding the level that everybody has got. Okay, so just give me a minute. Okay. Okay, so let people join in. See, what I feel is that every one of you may have gone through BSc level quantum mechanics, right? So, what is the way ahead? So, way ahead is that a few of the interesting topics, let's say the topics which require a good amount of derivation, that I'm going to give you as a recorded lecture. Okay, why that is so? Because see, if I'm going to do this entire derivation kind of stuff in this particular lecture, then we'll not be able to cover the previous year questions of the exam also. We'll not be able to cover the entire syllabus. Okay, so when it comes to little more, you can say derivation part, then what I would do is I would record some lectures. Apart from it, I'll send the link or I'll send the link beforehand. Let's say that is why actually. So today actually I thought what to start with. So I'll start with basic curve sketching at first because this is quite basic. And once you know how to sketch different curves, I mean this will be an important thing for you. Okay. Another lecture that I've scheduled is of mathematical physics. So in Sarthak Initiative, initially we are beginning with two of the most important topics, that is quantum mechanics and mathematical physics. It may so happen that after certain quantum mechanics, we may shift to some classical mechanics like you can say Lagrangian, Hamiltonian, and all those things. But initially, we will focus on these two important topics because you see, if you cover all these four topics, that is five topics: classical mechanics, quantum mechanics, mathematical physics, statistical mechanics, and EMT. I think you are more than sufficiently above the cutoff. Still, if you have certain doubts that probably you may not be able to clear it, do one thing, that is digital electronics, a few topics of analog electronics, a few topics I'm saying, not everything. Okay, because see, I was never passionate about electronics as such because I was always into theory, but lately my life took it to experimentation. And when I went into experimentation, then I found that if I had a good knowledge of electronics, I could have performed better. So you should have a sound knowledge of electronics, at least sound me, at least some good knowledge of electronics if you want to enter into experimentation. And then you just take some selected topics from modern physics. So only selected topics, not problems, selected topics from modern physics. That I'll let you know, don't worry. Okay, that I'll let you know. So for example, magnetism, for example, superconductivity, for example, you can say band theory, or there are topics like Raman spectroscopy. Okay, so laser. So these are the topics where you can expect each year questions to be asked. So in modern physics, instead of preparing end to end each and every line, just go through the previous year question. Obviously, I'll go through and I'll teach you also accordingly. But on your end also, I'm saying this is the best strategy that you can make for yourself. That is, consolidate these five subjects along with some selected portions of modern physics and selected electronics, and you are through the cutoff and you are through very good score also. If you are going to do each and every topic, probably you may be left out. So that is my suggestion. I would be helping you in these five topics and in selected problems of modern physics. For these two topics, as I told you, I'm actually into conversation with some faculty. I'll let you know in a month or so. Okay, but all these topics I'm going to take. Again, I'm reiterating, we'll start with quantum mechanics and mathematical physics. For initially, today you have 3 links that I've sent. From tomorrow, you will have a single link. So from tomorrow, we don't have this hiccup of 45 minutes and then we have to join with some other link. From tomorrow, we'll have a smooth sail. But for today, we have this thing. Secondly, I don't know the level of quantum mechanics everybody knows. Okay, but I would assume that everybody is aware of Schrodinger equation, one, and that everybody knows wave function. I'm not saying you know that how wave function is conceptualized by the formulation of wave packet. I'm not concerned there. I'm just concerned that whether or not you know what is Schrodinger's equation. If you know that, you are done. Secondly, a few of the mathematical things that you need to understand, for example, basic curve sketching, for example, Dirac delta function, and some little bit amount of association with linear vector spaces. Again, I'm saying the difficult portions for linear vector spaces or probably of quantum mechanics, let's say some derivational aspect, I will record and I will send you. I'll send you the previous day. Let's say we are discussing Schrodinger equation, or let's say we are discussing some concept which, let's say we are discussing tunneling, and you know that if I am going to write each and every step of tunneling and derivation, then we'll not be able to cover the syllabus. Are you getting my point? You are all MSc students. You know that quantum mechanics is covered in 2-semester course. Okay, so if I cover the entire MSc syllabus word by word, derivation wise, then it will take me almost 1 year to complete the entire syllabus. So how will we be able to make justice with our end goal, that is to clear the NET exam or GATE exam, or let's say if anybody is of JAM or something. So this would be a very good idealized strategy. Now I would like to tell you that I'm starting with basic curve sketching. This is because it will be a warm-up for each one of us that we have joined today, and you will be able to assess how much you know in this particular field. Secondly, also understand that I have already recorded these sessions. Okay, so I'll go in brief with these sessions. I'm not going to describe it very detailed, but I will also send you the link where I have done some 2 or 3 lectures on this entire topic. Okay, for example, today I'm going to touch upon Dirac delta function also, which you will find that I have almost 8 lectures there. I think 3 lectures, basic ones, and then there are lectures on quantum mechanics only. So I'll send you the links. So this is how we are going to do. In mathematical physics, I will recommend you each day a few lectures of complex analysis, because this is important. Okay, once you go through these lectures, these have been already done. I will schedule a class which will only have a discussion on previous year problem and concepts. So for example, in class, the complex analysis, if you are going to, I'll give you the link of the videos that I have already recorded. We have already done, like 3 months back we have done. So don't worry, I'm going to go through each one of these topics, but what I'll do, I'll take a different approach. Let's say you have done till identification of singularities. So I'll teach you identification of singularities along with the previous year questions. So in those lectures, we have not done enough previous year questions. So this will be a good strategy in which we'll be able, in which way we'll be able to cover complex analysis. Around 37 lectures are there on complex analysis. And they are very exhaustively covered. Complex analysis has been exhaustively covered. So what I'll do, I'll give you 2 or 3 links per day. You just see it in the speed of 2x, and remaining, and the next day I'm going to cover what was the gist of it, and I will cover it side by side with your previous year questions. So this is the strategy. I hope everybody has got. If anybody has got any doubt, please let me know right now so that we may start. Anshul, do you have any doubt? Harshit, Monica, Siddhi, Yash, and B. Okay, somebody is. Okay, so let us start with basic curve sketching. So see, why curve sketching is so important? Because most often in the exam also, probably a question may be given to you, and then answers are in the format of curves. Different curves are asked. Or, for example, there are times where going with curves may help you in your examination. So, okay, sorry. No, certainly. Okay. So what is an ideal strategy of drawing a curve? So there many coaching institutes do refer you a book of curve sketching. As much as I know, some Delhi institutes refer you a book of JE. I will never refer you that particular book, because see, the requirement of JE is different and your requirement is different. And particularly you are a physics person, so you should have a firm only a brief understanding of how to go through. I mean, and I also understand that what all curves are asked in your examination. So let us begin. So before starting a curve, first understand what is the function like. So we are dealing with the real valued functions only. So we'll be dealing with the real valued functions of real variable only. So we'll be dealing with the real valued function for real variable only. And if we are dealing with the real valued functions of real variable, the first thing that comes to mind is to find what is the domain of the function. And you are all wise enough to understand that domain means what? I mean, domain set means what? Domain set means where your function is defined. Where your function is defined. So for example, if I ask someone, what do you think that your function 1 upon x domain would be? So instantly you would say that it would be r except 0. So in except 0, you can have everything. Because if you add a 0 here, I mean, if we divide anything by 0, then it is not defined. And I hope you understand why it is so. Because see, if I divide by 0, it is not defined because what multiplies with 0 gives you 1. So there is no such number. So therefore, this quantity remains undefined. So therefore, 1 upon x would be defined for all real x, but it will not be defined at x equal to 0. So this is first. So first, always identify for which set. See if there is some symmetry that you can associate with. By which I mean, please see that whether the function is odd or whether your function is even. Now you would say that, okay, what if your function is root over x? So obviously this is not what I'm saying. For example, if a function has certain sense of symmetry, let's say x square, let's say x cube, then you may say that you can transform them by actually replacing x by minus x. Okay, here the minus x itself is not in the domain. So you'll not argue that what to do about these functions. We'll see what to do about these functions. But for functions where you can have certain sense of judgment by saying that whether they are odd or even, then there is a help. What is that help? Odd functions are always symmetric about y-axis. Odd functions are always symmetric about origin. And even functions are always symmetric about y-axis. A basic understanding to this you can form by saying this. See, what are odd functions? Odd functions are those where if you replace x by minus x, you get minus fx. Okay, so if you are actually making a graph of odd functions, so if you are having these ordered pairs x comma y, let's say this is your x comma y. So if you see, think about minus x, so just see there is a symmetrically opposite corner here, minus x. This would be minus x, right? This is x, then this would be minus x. At minus x, what you will have? I mean, what you will have? At minus x, you will have minus of y. Are you getting my point? See, always remember, in calculus, we say y is equal to fx, but in coordinate geometry, this is your y coordinate and x is your x coordinate. So fx is simply but your y coordinate. But in calculus, we know this y coordinate is nothing but it is a functional value of the point, that is fx. So if I want to find what would be the value of y at minus x, this would be f of minus x. Yes. And what is f of minus x? F of minus x is minus fx. And what is minus fx? I can write it as minus y. So in a graph of an odd function, if you have the point x comma y, you are definitely going to have a point of minus x comma minus y. And you can see that this symmetry is about origin. I'm not saying that perfectly the graph would be a straight line or something, but always remember in odd function, if there is a point x comma y, then there certainly will be point minus x comma minus y, which asserts that there would be symmetry about origin. Is that clear? Similarly, on contrary, in even functions, what is the case? If you have a function point x comma y, then you will have a point minus x comma y. Why? Because for even function, if you replace x by minus x, your function would remain the same. So if there is a point x comma y, on the other hand, if I replace x by minus x, you can say the image of the point of minus x also remains y. So you'll have a symmetry about y-axis. I hope it is clear. If there is any doubt, please let me know. So for even functions, you have a symmetry about y-axis. Is that clear? Okay. Now you see. Okay, good. Okay. So, what else I can do? See, this is one. Now what I'll do? See, third point you should remember: is there any asymptotic kind of variation? Now, what do I mean by asymptotic kind of variation? What do I mean by asymptotic kind of variation? See, if you have a function 1 over x, so you know that as x tends to infinity, 1 upon x tends to 0. So if I want to plot the graph, and if I see that what will happen as x tends to infinity, 1 upon x goes towards 0. And if it goes towards 0, what would be happening? This particular line and this particular distance from which from where we have to take the distance? From the line y equal to 0. See, this distance approaches close to 0, not exact 0, but close to 0. So this distance approaches close to 0, but not exact to 0. But not exactly. This kind of variation in mathematics is called as asymptotic variations. Or you can say that the graph 1 upon x is having asymptote, is having horizontal asymptote here. Are you getting my point? Is that clear to you? Okay, so this is called asymptote. Okay, so this is called asymptote. Here you can see there is a vertical asymptote. Here's a vertical asymptote. So please do see that if there are some asymptotes forming, then this also you should take in consideration. Another thing that you need to remember is that whether your function is, what the function's limits are as x tends to plus minus infinity. How does that function behave? So how does your function behaves at very large values, at very large positive values, at very large negative values? Also remember, how does your function behave at origin? Is it defined? Is it not defined? All those things. Then just have an idea of 4 of the things that I'm writing. Just pay attention. F dash, F double dash. Only these 2 things you have to remember. These are this will give you a solid idea as to how the graph will be formed. You see, I have discussed this thing in detail in other lecture. I'm going to just give you a hint right now so that you can just fix your mind as to what I'm saying. Okay, so these are the 4 cases that I'm going to draw for you. See, mostly in our syllabus, or probably till now in physics, we are going to deal with smooth functions, mostly smooth functions. Okay, so the derivative is defined, it is continuous. The second derivative is defined, it is continuous. If this is the case, obviously one can argue that, let's say, what if I make a graph of greatest integer function? So I'm not discussing those graphs right now. I'm discussing graph of the smooth functions. Okay, where your first derivative is defined, continuous, second derivative is defined and continuous, and other higher order derivatives are also continuous and are continuous as well. So all these functions I'm right now concentrating. Now, the first case is that if my function derivative is coming positive, let's say for some interval, I, it so happens that f dash x is greater than 0. Then what will happen? This is so for example, if you know from your standard 12th class, if a function is defined on interval I to j and f is an increasing function, then f dash should be greater than equal to 0 for all x belongs to I. Okay, this is how you characterize a you can say an increasing function on an interval. Okay, and I'm saying all these things very carefully because for mathematics people things may again change. So for interval I, this is true, and for physics people, yes, we are dealing mostly in real number systems only, or for real lines only, or for a connected space only, more technically. So fine. So if my f dash x is greater than 0, this is deemed to be, this is what is called as that my f is increasing on I. Now you just see if f double dash x, how does that behave? If that is also greater than 0, then I would say that my f dash is increasing, isn't it? So for f to increase, you should remember that f dash should be greater than 0. And if f double dash is greater than 0, I would say that my f dash is increasing. If this is the case, this is what I refer to as increasing at an increasing rate. Increasing, function is increasing, yes, indeed, because f dash x is greater than 0, but at an increasing rate. Increasing at an increasing rate. Whenever you have this kind of thing, always remember your hands should go in this manner. This is how you plot a curve of increasing at an increasing. Okay, all these things I have discussed in detail in my lecture of basic mathematics for physics. I will give you the link, don't worry. But right now, just keep in mind, if I have to make the graph of increasing at an increasing rate, your hand should go this way. Okay, has anybody got any problem? So let me explain also if you are that interested. See, what happens is, always remember, derivative at any point refers to the slope of tangent drawn at that point. You can see the slope here is always positive, isn't it? So all these thetas are acute, and if theta is acute, then the tan is positive. So if tan is positive, at every point, the slope of tangent is positive. So for every point, if the slope of tangent is positive, then it implies that f dash x is positive. Is that clear? And if f dash x is positive, then I would say that my function is increasing. Now, secondly, see, these angles are also increasing. So your tan theta is also increasing. What is tan theta? Tan theta at any point represents what? It represents the derivative. So let's say this is theta 3, this is theta 2, this is theta 1. So clearly theta 3 is greater than theta 2 is greater than theta 1. And tan itself is an increasing function for 0 to 90 degrees. So I'll write this way. So I can say that what is increasing? My f dash x is also increasing. So it implies that my function is increasing at an increasing rate. This is how we trace function increasing at an increasing rate. Is that clear? Has anybody got any problem? Sorry. Harish, I'll give you the example. Don't worry. So put all these things in one example, and that I'll show you. Don't worry. Meanwhile, you just understand. Are these all things clear? Okay, good enough. Now, if I want to make a graph of increasing at a decreasing rate, so what is increasing at a decreasing rate? Your function is, the derivative of function is positive, but the second derivative is negative. Here you would say that your first derivative is also positive, your second derivative is also positive. Here your first derivative is positive, but second derivative is negative. So increasing at a decreasing rate. In this particular scenario, your function, your plot will be this way. Increasing at a decreasing. Now, if you just consider the slopes are decreasing. Okay, the slopes are decreasing. If slopes are decreasing, that implies f double dash x is negative. What is slope? Slope is as f double dash. If you just, I'll just let you know here. You see, this is how your variation is. Okay, so you see, if I just make the slopes around, or you can say tangents around. You can clearly see that angles are positive. Angles are in 0 to 90. So if thetas are between 0 and 90 degrees, sorry, I've used this notation. I don't like this notation. Okay. If angle is between 0 and pi by 2, my tan is positive. And if tan theta is positive, that it implies f dash x is positive. Implies function is increasing. But you see, these slopes are decreasing, isn't it? I mean, you can clearly see this theta is more, then this theta is less, then this theta is even lesser. So if I mark again like tan theta 3, tan theta 2, and sorry, theta 3, theta 2, and theta 1. So I can clearly see that theta 1 is greater than, and this is how it is. And tan is an increasing function for 0 to 90. So clearly tan theta 1 is greater than tan theta 2, is greater than tan theta 3, And you can see that all this, your slopes are decreasing. So f dash x is decreasing. If f dash x is decreasing, it implies f double dash should be negative. So this is how you make a graph of increasing at a decreasing rate. Now, if you have to make a graph of decreasing at an increasing rate, okay. So there was a power cut. Am I audible right now?
Yes, sir.
Okay, good enough. So just give me. So these days the monsoons are there, so you can expect some hiccups. I cannot help it. So okay. So I think this is clear. Now you see. Okay, I hope it is clear. Now you see, if I was discussing about decreasing at an increasing rate, right? So if I'm decreasing, I have to see a graph of decreasing at an increasing rate. Then how would I make? This would be decreasing at an increasing rate. And this would be decreasing at a decreasing rate. Sorry. It has become decreasing at a decreasing rate. So what is decreasing at a decreasing rate? This will be like this. I hope these four, you can say curves, you should keep in mind always. And this is how your basic curve sketching works. There's no other physics around. Just keep this in mind, that if you know these four curves, you will be able to plot any graph in this entire, like smooth graph I'm talking about, right? So let us begin. Okay, let us begin with few examples and then we'll see. So one of the standard example that I took in the video also is e to power minus x square. And again, I'm going to take that example only because that happens to be a favorite example. So let us take the graph of Gaussian. What is smooth graph? Okay. So by smooth functions, we mean that the derivatives are continuous. So derivatives are continuous. So if I am referring to a mathematically smooth function, I refer to it as functions whose derivatives are continuous. Okay. So for example, you can take one of the graphs, let's say e to power x. So you know that the derivative of e to power x is e to power x. Again, e to power x is a continuous function. Okay. If you take a graph of, let's say, greatest integer function, then there would be a problem. There would be a problem. It will suffer discontinuities at integers. Okay. So all those graphs I'm right now not focusing. I'm right now into the graphs which are where you have like I mean, life is very simple for all these kind of things, right? And mostly in physics, we'll deal with these functions. If I'm not dealing with these functions, let's say one of them is Dirac delta function, that I'm going to just narrowly explain you in around 10 to 15 minutes. And then most of the things you can see in those lectures only. So because actually we have covered all these things and I just want you to go through them. But I just wanted to make a synopsis around so that things remain easy for you. Okay. Okay. Okay, so let us make a graph of e to power minus x square, well-established function, no issues with this function. You know how it is plotted usually, but let us do an exercise of what we have learned. What is the domain of this particular function? You know that the domain of this particular function would be R. This is defined for all real R. What do you think about function being even or odd? Clearly, this function is even. You replace x by minus x square is again x square. It's not going to matter. What do you think? How would you think that your function behaves at x equal to plus minus infinity? So whether it is plus infinity or whether it is minus infinity, e to power minus x square would go to 0. Because if x tends to plus minus infinity, your x square anyway would tend to infinity. And if x square is tending to infinity, e to the power minus x square would tend to 0. I hope it is clear. At 0, it would be at 1. At infinity, it is going to tend towards 0, whether it is plus infinity or minus. I hope it is clear. Now, what you could do, is now you have to see the derivatives. So differentiate it. So if I differentiate it, what I'll get? Minus 2x e to the power minus x square. So minus 2x e to the power minus x square. You see what you can say about this particular function. E to the power minus x square is always, e to the power minus x square is always positive, 2 is positive. When this particular derivative would be positive, this particular derivative would be positive only if x is negative. And this particular derivative would be negative only if x is greater than 0. Is that clear? So for all x greater than 0, your function, for all x greater than 0, your function is decreasing. And for all x less than 0, your function is increasing. I hope it is clear. Is that clear? Because we are having around 8 minutes to the meeting. So tomorrow we'll not have 3 links, we'll have single link. But today we have just started. So I hope it is clear. Good. So just think about f double dash x. What could be f double dash x? F double dash x would be minus 2 e to the power minus x square plus 4x square e to the power minus x square. So if I take a e to the power minus x square common, we'll get 4x square minus 2. See, when it is positive, it will be positive only if x square minus 1 by 2 is positive. X square minus 1 by 2 positive means x square minus 1 by 2 positive means x belongs to minus infinity comma minus 1 upon root 2 union 1 upon root 2 comma infinity. Okay, so this inequality I'll write somewhere so that you never forget. I mean, this is an important inequality, and I'll again send you a link for this particular lecture as well, where I've explained these quadratic inequalities. But right now, just consider this. And if I have to see when my f double dash x would be less than 0, somebody's annotation is on. Okay, so, if f double dash x is less than 0, then it implies your x should lie between minus 1 upon root 2 comma 1. Is that clear? I mean, this is clear or not? Because see, e to the power minus x square is always positive. So if this entire thing has to be positive, then this should be positive. If this entire thing should be negative, then this should be negative. Is that clear? So what we're getting right now about e to the power minus x square is that this particular function, if I distribute it into 4 parts, let's say from minus infinity to minus 1 upon root 2 is one part. From minus 1 upon root 2 to 0 is another part. From 0 to 1 upon root 2 is another part. And 1 upon root 2 to infinity is another part. What I have already got. For all x greater than 0, my f dash x is negative. So for all x greater than 0, this is first case where f dash x is greater than 0. So f dash x is greater than 0. Sorry, f dash x is less than 0 here. Here also f dash x is less than 0. And here you have this f dash x greater than 0. Here you have this f dash x greater than 0. Okay, now what about f double dash? So I have come to know that for f double dash x would be negative here. It would be positive here, sorry. In minus 1 upon root 2 comma 0, here it is. Here f double dash x is negative. Here f double dash x again is negative. From 0 to 1 upon root 2, it is again negative. And from 1 upon root 2 comma infinity, f double dash x is positive. I hope this is clear. Is that clear, guys? Students, is that clear? Okay. So I hope it is clear. Okay, good enough. So what I'll do now, also remember this particular function was even. Okay, so whenever even function comes in exam, what freedom you can take? You can take a freedom of making the graph. You can take the freedom of making the graph for positive real axis and do the same for this side. This is one of the strategies that you can do. But right now it's not even necessary, let it be. Okay, so right now I'm making the entire graph, and I'll show you that this particular graph would be symmetric about y-axis. This I'll show. But in exam, because you have lack of time, so you can use this kind of thing that I'll make the graph only for x greater than 0, and apart I'll just copy paste this graph. In mathematics, we say that if I'm making a graph here, I'll take the reflection of this particular graph on x greater than 0, taking y-axis as a mirror. So just make that particular graph here. So one thing that you can do in exam to save, but right now my idea is not to save your time. My idea is to give you what I have taught you. That I have to show you what I have to show how it implicates. Okay. So now we are going to make the graph. Remember, what was the first thing that I told you? How would your function behave at x equals to plus minus infinity? So clearly the function is asymptotic towards x equals to plus minus infinity. It is going towards 0. Okay, so as x tends to infinity, e to the power minus x square is going towards 0. Is that clear? So it is being asymptotic. So I told you it is being asymptotic. Okay, now what happens? Just in your mind, or right now I'm just plotting it here, minus 1 upon root 2. Although in exam you don't have to show all these things, but right now I'm just showing all these things. Now you see, from minus infinity to minus 1 upon root 2. From minus infinity to minus 1 upon root 2, function is increasing at an increasing rate. How to go about it? Increasing at an increasing rate. Is that clear? Now, function is minus 1 upon root 2 to 0. Function is increasing, but at a decreasing rate. How you have to go about it? You have to make your hands go like this. Okay, obviously, not exact graph I'm drawing, but you see, this is not an expanse of minus infinity comma minus 1 upon root 2. Obviously, this expanse would be very large as compared to this expanse. But let's say I've made it in this manner, so let it be. I hope it is clear. Now, from 0 to 1 upon root 2, from 0 to 1 upon root 2, function is decreasing at a decreasing rate. Decreasing at a decreasing rate. Your hand should go this way. So decreasing at a decreasing rate. Okay, and from 1 upon root 2 to infinity, function is decreasing at an increasing. So this is how your Gaussian looks like, and this is how your graph is. Obviously, exactly it is not the case, because 1 upon root 2 happens to be quite close to 0, and infinity, like on this particular relative scale, I would take it at very large distance. But I hope you've got this particular thing. Is that clear or not clear? Okay, so this particular question was asked in GATE exam. Okay, it was asked that e to the power minus x square is differentiable at 0 or not. So clearly it is differentiable at 0. And the comparison that was asked in exam was with e to the power minus mod x, which we shall continue in the next lecture. Okay, so please join in the next lecture, and I'll let you know how to plot the graph of e to the power minus mod x. I hope everybody has got what I wanted to convey. Okay. And we'll come to the topic. Don't worry. In a day or two, I'll come directly to the topic quantum mechanics. But till then, I just want to do a little bit of justice of whatever I have already done. Okay. So, for example, in quantum mechanics, I'll directly begin with postulates. Although there are already 3 lectures on postulates that I've kept, and I'll also record a few of them in very much detail, so that I don't have to derive each and everything in the class. So in class, we'll focus only on theory part, understanding that theory part, and applying that theory part with the question of exam and other questions as well. Not only exam, but other questions also. Because see, at the end of the day, in exam, how you derive the expression doesn't matter. How you applied that particular knowledge matters. So I hope you understand. Okay. So we'll meet in the next session with e to the power minus mod x. Till then, take care.